In this lecture, we are just going to look at a bunch of different examples where we are factoring expressions in multiple ways. Okay? So first and foremost, the biggest thing about factoring is being able to recognize what type of factoring you have to use with the problem that you're trying to solve. So in this case, I have a trinomial. So the first thing I want to do is I want to try and see if I can factor out a greatest common factor. Well, my greatest common factor here between 12, 28, and 24 is going to be 4. So my first act is to pull that out. So pull out the 4 and then reduce it. You get 3x squared plus a 7x minus 6. Now here, in looking at this, I have a coefficient on my first term that's greater than 1. So whenever that happens, the easiest thing to do is to do what's called the bottoms up method. At least that's what I like to call it. It's also known as the AC method. So here, what that means is we're going to ignore this little 4 for now, but I'm going to go ahead and circle it so that we don't forget him at the very end. Now I'm just going to work with the values that are here in my parentheses. So A times C is the first piece, and in this case this says take your first term, so 3, times the last, negative 6, which is going to give me a negative 18. The second thing that I want to do is I want to find factors of that negative 18. So there's a couple ways that we can do that. You can list them all, or you can try and list the one you think is going to work. I highly recommend in the beginning listing all your factors until you kind of get more confident with what you're doing. So here we know we have factors of 1 and 18, 2 and 9, 3 and 6. Okay. Now, of these factors, what we want to know is we want to know which factor pair adds to the B term. So here we want to add to a positive 7. We have a negative factor, so that means one factor is positive, one's negative. And because my middle term here is positive, what that actually means is that the smaller factor is my negative factor. So here we're going to have negatives on this side, so we have the bigger factor is positive. So in this case, the factor pair that I want to use is this middle one right here. 9 minus 2 is 7. Once you identify your factor pair, we need to set up your factors. So we want to set up the factor x plus or minus factor over the A term. So this is going to be our setup for bottoms up. So here we are going to have x, we're going to have plus 9 over my A term, which is 3. And we're going to do it for the other, x minus 2 over 3. Now remember I said we don't want to forget our little buddy 4, so we're going to go ahead and bring him down. And now we're going to reduce. So what we want to do here is you want to reduce each fraction to lowest terms. So here this 4 is going to come along, and then we're going to have x plus 3, because 9 over 3 reduces to 3, and x minus 2/3, because 2/3 won't reduce any. The last thing we're going to do now is we're going to do bottoms up. what bottoms up mean is any denominators that are still left, like this 3 down here, are going to go ahead and shift themselves up to become the coefficients of the x term. So here we end up with 4 times x plus 3 times 3x minus 2. Now if we were to multiply this whole thing back out again, we should come up with the polynomial that we started with. Alright, let's go ahead and look at a different one. So here I have 24x to the 12th minus 375. So this right here is actually going to be a difference of cubes. And in this state it might not look like it, so let's go ahead and prove it. First and foremost, I have a greatest common factor of 3. So let's go ahead and pull that out. So this becomes 3 times, this is 8x to the 12th minus 125. If you take a look, 125 is a cubic value and 8 is a cubic value. So we can go ahead and we can rewrite these in terms of their cube counterparts. So this is going to end up being 2x to the 4th cubed minus 5 cubed. Now, one thing that we know is we know that we have a difference of cubes formula, and that difference of cubes formula is what we're going to reference here. So the formula itself is going to say that because this is a subtraction, we have a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So what we have to do is we have to identify the a and the b. So we're looking at just these values in here. And we know my first part, so here my a is going to be representative of 2x to the 4th. My b term is going to be represented by the 5. So what we have to do is we just simply have to plug into our formula. So we're going to bring the 3 down. Then we're going to look at the first part. The first part is a minus b. So 2x to the 4th minus 5. Then we're going to multiply that by the second part. So this is going to be 2x to the 4th squared plus 2x to the 4th times 5 plus 5 squared. So here we have 3 times 2x to the 4th minus 5. And we have to do the math. 2 squared is 4. X to the 4th is going to end up being x to the 8th plus 2 times 5 is 10 x to the 4th plus 25. Alright, let's look at another one here. Here I have 3x to the 4th minus 48. In this case, we are going to have a difference of squares. Again, my GCF is 3. So 3's got to come out, and this is x to the 4th minus 16. So we have our difference of squares here. So our difference of squares, again, we're going to break this down the same way we did the cubes. So we've got our 3. This is going to become x squared squared minus 4 squared. So a is going to be x squared. B is going to be 4. So in this case, we're going to end up with 3 times x squared plus 4 times x squared minus 4. Now, when we work with difference of squares, you always need to make sure that you don't have more than one. And if we look at this piece right here, notice we have a second case of difference of squares. Because we have a second case, we can reduce this further, so we have to keep going. So in this case, we have 3 times the x squared plus 4. And then here, my difference of squares, this is going to be x squared minus 2 squared. Again, to finish it out, this is going to be x squared plus 4, and then I'm going to have x plus 2 times x minus 2. Since I cannot reduce any of these factors any further, then we are going to we're done. Alright, this factor is a little different. This factor has 4 terms. 4 terms says that we are going to use grouping. Grouping says we're going to look at the first 2. So we're going to look at just these first 2 terms. We're going to ignore the back 2. And we're going to look at what is actually in common between these first 2. So here I've got an m cubed and m squared. So I'm going to pull out the m squared, which leaves behind m plus 6. Then I'm going to carry the rest of the problem down, minus the 2m minus 12. So now we are going to look specifically at the back half here. So what's in common here is I've got this negative 2. So I'm going to pull out a negative 2, which leaves behind m plus 6. I'm going to drop down what I initially had. And now what I want to make sure is that this factor and this factor, they must be the same. If these two factors, these two here, end up being something different, then you've either done your grouping wrong or this problem can't be solved by grouping. So they should come out to be exactly the same. If that's the case, then you're going to write the 2 outer terms together. So here we have m squared minus 2 and the 2 inner term, or the 2 factors as 1, m plus 6. And that's all there is to it for grouping. Alright, let's take a look at another one. In this case, I have a greatest common factor of 3x. Notice I have an x in all of my terms. So I want to make sure and pull out all of the factors. So this is going to become a 3x on the outside, and it's going to leave me with 6x squared plus 17x plus 5. Again, we can use that bottoms up method. So we're going to start with a times c. So a times c is going to be 6 times 5, which is going to give us a positive 30. We want to look at our factors. So we have 1 and 30, 2 and 15, 3 and 10, 5 and 6. We want to know which combination of these is going to give us the positive 17. So when we do that, since everything is positive, we know plus 2 plus 15 is going to give us the answer, the factor that we want. So those are the factors we're going to use. Once we know that, we can set ourselves up. So we have my 3x, because that's what I pulled out. Then I'm going to have x plus, it's going to be my factor, so 15 over my a term, which is 6. And then x plus the 2 over my a term, which is 6. Now that it's set up, we want to reduce these fractions. So here we've got the 3x still. 15 over 6 is going to reduce down by 3. So here we're going to end up with x plus 5 over 2, and x plus 1 over 3. Last, I've got a 2 on the bottom here, which can come up, and I have a 3 on the bottom here, which again can come up. Therefore, 3x times 2x plus 5 times 3x plus 1. Alright, now, real quick as a refresher, multiplying these two binomials together, the reason we're doing this is because notice there's lots of variables here. So let's just go through real quick as a refresher how to do that. Remember here you are going to use the FOIL method, first, outer, inner, last. So first is going to be 2x and 3x, so this gives you 6x squared. Then we have a 2x and a negative 2y squared, so this is minus 4xy squared. Y squared and 3x, so plus 3xy squared, minus y squared, or plus y squared minus 2y squared is going to give me a negative 2y to the 4th. This place right here can combine, so we end up with 6x squared minus xy squared minus 2y to the 4th. Next, or the last thing I wanted to look at is another example of a cubes, but in this case we are using the sum of cubes. Now just like before, it doesn't necessarily look like it right off the bat, so let's go ahead and rewrite this in terms of cubes. So my 64 can be rewritten as 4, and then my m to the 21st is the same as m to the 7th cubed. Now the reason for that is because 7 times 3 is 21. Okay. Now we're adding these, so let's do the other one. 27 can reduce to 3, and then this becomes n to the 6th, and this is cubed. Now just like before, this is my A piece and this is my B piece. So when we have the sum of cubes, again we have the same kind of formula. The only difference is going to be the location of your signs. So here our formula is A cubed plus b cubed, and this is going to give us a plus b times a squared minus ab plus b squared. So just like before, the only thing that we have to do is just plug our information in. So here we are going to end up getting 4m to the 7th plus 3n to the 6th times 4m to the 7th squared minus 4m to the 7th times 3n to the 6th plus 3n to the 6th squared. Now just like with the difference of cubes, we need to do all the math. So here we're going to have 4m to the 7th plus 3n to the 6th times 4m to the 7th squared is going to be 16m to the 14th. Then we're going to have minus, we are going to have 12
It's just everyone will relax fire until
m to the 7th, n to the 6th, and then we're going to have plus 9 n to the 12th.
Of course, you can drink whatever you like. Thank you, Major. I appreciate your support.
So, there we have it. Everything that we need in order to work on all different types of factoring. So, if you have any questions, please let me know. Otherwise, I do hope you enjoyed yourself, and I look forward to talking with you next time.